Welcome to homework help video for lesson 5.2. Today we're going to deal with fractional exponents. We'll be doing these problems from the homework. Okay, so some from each problem. All right, so before we get into this, let's talk about our conversion rules. We learned about fractional exponents for the first time, really, for the majority of us today. So let's take down these notes before we get started. If I have x to this fraction exponent, I have two pieces, the numerator and the denominator. I'm calling the numerator p because it represents the power. I'm calling the denominator r because it represents the root, or what goes in the radical. Okay, so the numerator is the power or the exponent, whichever term you prefer, and the denominator is going to be the root or the radical. This is what I mean. If I want to rewrite this, x to the p over r, well, the denominator or the root would come out here as part of this root symbol, and then x would remain to the power of p. So you see that the numerator stays the power and the bottom becomes the root. This is one of the most famous ones that you'll see a lot, which is x to the power of 1/2. So when I'm rewriting this, I'll get the root of x. Now, the root is going to be 2. My power is going to be 1. But we don't really have to write x to the 1 because we know that's just x. And interestingly enough, we don't actually have to write this 2 here either. We can just leave it off. Whenever there is an invisible root, it's actually always a 2. Just like how whenever there's an invisible exponent, it's really a 1. Let's make a note of that to ourselves. Invisible exponent, if you're missing one, it's always a 1. But if you're missing a root, the invisible root is always 2, which would be the square root. This is pronounced the square root of x. Let's do a couple more famous ones. If I have, so let's do a quick sidebar right here. If I have x to the power of 1/3, I'm going to rewrite that as the third. 3 would be my root, and then x. This is pronounced the cube root of x. Similarly, if I have x to the 1/4, can you guess what goes out here? If you said 4, you'd be right, because this would be the 4th root of x to the 1, or just the 4th root of x. Okay, so I hope that you feel a little more comfortable with our conversion rules. Let's jump into our first problem. Okay, it says let f of x be x to the 1/2. All right. G of x is going to be to the 1/3. And then h of x will be to the 1/4. And we need to find h of 81. So if I want h of 81, I'm going to be plugging in 81 for x right here and for x right here. So I'm really interested in 81 to the power of 1/4. Well, we know how to rewrite this because if I have a fraction exponent and I need to rewrite it as a radical, the number that is my root is always the denominator. So this is the 4th root of 81 to the power of 1, or just the 4th root of 81. Now here's what this question is asking. What number times itself 4 times? So what number do you multiply by itself 4 times? If I were to stick it in each of these brackets here, will give me 81. Okay, that's the question. That's what this is asking us for. What number times itself 4 times gives me 81? The answer is 3. 3 times 3 times 3 times 3 is 81. This is just something that you should memorize. 3 to the 4th power equals 81. So we have found our number. The answer is 3. The fourth root of 81 is 3. You should also memorize these ones. 3 cubed is 27. 3 squared is 9. 3 to the 1 is, well, that's just 3. And anything to the 0 power is 1. So you should be super comfortable with these basic base 3 exponents. Take a minute and do these ones with me also. Okay, so anything to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. 2 times 2 times 2 is 8. 16, and then 2 to the 5th power is 32. These are some super important ones to memorize. Let's do our 4s. These are the important ones. And then finally, let's talk about 5. These are important ones that come up just again and again in this class, in calculus, on the SAT, so it's good to know them. So anything to the 0 power is 1. 4 to the first power is 4. 4 squared, that means 4 times 4 is 16. And 4 times 4 times 4 is 64. Just become comfortable with these. So if I say, what cubed gives me 64, you should be familiar that that would be 4. And then finally over here on the right side, 5 squared is 25, and 5 cubed is 125. So if you don't already have these like in your head, take a minute to memorize them forwards and backwards. All right, coming back, we're going to continue with number 1D. So I want to take negative 125 to the power of, I'm looking here, so to the power of 1/3. So here's our question. We need to, before we break this down, rewrite it as a root. So the number that goes over here, recall, that is always our denominator. So we're interested in the third root of negative 125 to the first power. But again, we don't usually have to write that to the power of 1 there. Okay, so what number can multiply with itself 3 times to give me negative 125? Well, we know that 5 times itself 3 times gives us 125. But I need negative 125, so let me see if this works. Let's try negative 5. If I take negative 5 and I multiply it by itself 3 times, these two together will give me positive 25. And then when I multiply it with that last negative number, I do get negative 125. So our answer in this case is negative 5. Now I want to draw a quick distinction here on the right side. If I had the, let's say, square root of negative 9, the square root of negative 9, or the cubed root of negative 8. Let's talk about these two problems. Okay, if it's invisible, the number that goes here is 2, remember? So what number times itself 2 times will give me negative 9? If you said negative 3, you have to think carefully. Negative 3 times negative 3 is positive 9. So see if you remember from unit 1, so this is not equal to negative 3. This is actually an imaginary number. 3i would be the answer. Because think about it. There is no number where if I multiply it by itself twice is going to give me a negative. So remember, whenever we have the square root of a negative, or in general, any even root of a negative number is going to give us an imaginary solution. But with this example, it actually is equal to negative 2. Because if I multiply negative 2 times itself an odd number of times, these two will become the positive, but then there's this one left over, which will bring me back to negative. So if I have an odd root of a negative number, my answer is actually going to be a real negative number. So my answer is just going to be negative. Okay. So the square root or the fourth root or the sixth root, these are all imaginary. The third root, the fifth root, the seventh root, those are all going to be negatives. So make sure you put this in a box somewhere in your notes. It's super important. Okay, let's go to problem number 2. So problem number 2 is just kind of going backwards. They're giving us a radical and they want us to rewrite it as a fraction exponent. So, well, we know that our power is 2, so that is our numerator. And then the 7 is our root, meaning it must have come from the denominator. So remember, the root goes into the denominator. The power stays up top. That's the answer. Let's look at D. Let's do the same thing. We have z to the power of some fraction. Our numerator is the power. It pretty much stays where it is. It stays up there. And our denominator is our root. So it's 6 over 3. Now that's not our final answer because, in fact, 6 over 3 simplifies down to 2 over 1. So this is really z squared. And that would be our final answer. So check this out. What if I asked you to do this? The square root of y to the 10th. First of all, we know we're going to have to rewrite it as y to the 10 over something. But what is that missing root number? Is it a 1 or a 2? If you said 1, you're thinking about invisible exponents. Invisible exponents, if there was nothing here, for example, would be a 1. But there is something there, obviously, it's a 10. But invisible roots are always 2. Invisible exponents are 1. So this would be a 2 here. So this is 10 over 2. Is that our final answer? Look at it carefully. No, it simplifies. So this will become y to the 5th power. Okay. F. So it doesn't matter. Let me clarify right now. It doesn't matter whether their exponent or our power is outside of our parentheses or whether it was inside of our radical. Our power is still our power. So when we rewrite it, it stays in our numerator always, and our root will always come back down to our denominator. Is this our final answer? Simplify it if you can. Our final answer is e to the 1 over 2. All right, problem number 3. So, I'm going to show you how I like to do these problems. There's 2 different ways to do it. I'll show you both, and then I'll tell you my favorite way. So one way we can do the problem, over here on the left side, is to rewrite this as 125 with the root of 3 and a power of 2. Another way, just slightly different, is to write it as 125 with a root of 3 and then the power on the outside as 2. So remember how I said it doesn't matter whether it's inside or outside, our power is still our power? So this is what I mean. These are equivalent to each other. But I'm just going to let you know right now that I like to do the one on the right side better, just because it lets me take the cubed root of 125 first. Now, I know what the cubed root of 125 is because I remember that 5 times itself 3 times is 125. So since 5 cubed is 125, that means the cubed root of 125 is 5. So the question being, what number times itself 3 times? Gives me 125, that would be 5. Okay, so since I know that the cubed root of 125 is 5, all I have to do in the last step is square it. Okay, so I brought down the exponent. And 5 squared is 25, and that's our answer. Now let's look back on the left side. Why is this more challenging? On the left side, first you have to do 125 squared. Now, I don't know about you, but I do not know what 125 times 125 is, and I do not care. Because you know what, I'm just going to do it the easier way, where I take the root first, and it gives me a small number, and then I can simply square it, or do whatever I need to with the exponent at the very end. So let's try this problem, F. So we're going to rewrite it. It's going to be 36 with a root of 2, which just means a square root, and a power of 3. I'm going to put the power on the outside. So it's up to you. Do you want to do 36 cubed first? Or would you prefer to do the square root of 36 first? I would like to do the square root of 36 first because I know that that's 6. And then the very last step, I'll cube it. So 6 times 6 times 6, that's the challenge. So 6 times 6 is 36 times another 6 gives me 216. I hope I did my math right, because I'm not going to lie, I didn't memorize 6 cubed. So, last problem. Use the rules of exponents to simplify the expressions. Okay, so here's what I want to emphasize. This says use the rules of exponents. So before we can even do anything with this, we should probably convert our radicals into exponent form, or like fraction exponent form. So our numerator would become 2 to the power of 5 over our root of 3. And our denominator would be 2 to the power of 4 over 3. Remember, your root becomes the denominator. The root became the denominator. Okay, now, see if you remember this rule from before. If I have x to the 5th power over x squared, you can really just subtract these. So 5 take away 2 is 3, and I'll be left with x to the 3rd in the numerator. This would be the visual idea. If I have 5 x's on top and I'm dividing by 2 x's on the bottom, after canceling, I'm left over with just 3 on the top. On the other hand, if I have x to the 3rd over x to the 4th, so we're going to subtract. And I'm always going to subtract so I get a positive number. So in this case, I'm doing 4 minus 3, and I'll get x to the 1. But is that going to be left on the top or on the bottom? So our rule is always with the bigger, wherever the bigger exponent was. In this case, our bigger exponent is on the bottom. That means we're going to have 1x left in the denominator, and no x's left up top, which is why we put a 1 over x. Here's the visual for that problem. I have 3 x's on the top, 4 x's on the bottom. 3 of them cancel, leaving me with a single x down below. That means I have to write 1 over x. So that was just a quick refresher of our rule, which is if I am dividing variables with the same base, I simply subtract their exponents. That's what we're going to do here. So I have 2 to the 5 over 3 divided by 2 to the 4 over 3. So I'm going to simply subtract. What's 5 over 3 minus 4 over 3? That leaves me with 1 over 3. And that's my new exponent. So I have 2 to the 1 over 3, but is that in the numerator or in the denominator? It's always with the bigger exponent. So it's going to be in the numerator. So that will be my final answer. Or my answer could be the cubed root of 2. Okay, so you're going to use the same idea over here with B, except notice that after you convert this into an exponent, which would be 2 over 3, and this would be 5 over 3. Instead of subtracting your exponents, this time you're going to add them up. So I hope that helped. Good luck with the rest of your homework. Look at how much we did today. We're such ballers. Check it out. Whoa. All right, bye.